compound interest. All right? So after T years, the balance A in an account with principal P and the annual interest rate, which is R, is written as a decimal, is given by the following formulas. So if you compound N times per year, meaning a certain number, like if annually is once, monthly is 12 times, right? Semi-annually is twice. Daily is 365 times a year, right? So, I mean, you could do hourly, minutely, whatever, but minutely, that sounds like a good word. A equals P times 1 plus R over N to the NT power, okay? And what I haven't told you in any of my videos, but this thing here, if you kind of let N tend to infinity, if you kind of let N get bigger and bigger and bigger forever, it approaches E. E to the, the R, the interest rate there. So that's kind of a math thing that's there. It's in a lot of college algebra books where they talk about that. But that's where that other formula, if you compound continuously, right? Compound continuously. And so, things where this might be pertinent in your life, the big deal is, like my savings account at the bank, I think it compounds quarterly, which means 4 times a year. So I would use this formula with 4. But you know what? If I borrow money from the bank, I can just about tell you they either do it daily, so this N is 365, or they use this continuously, where they're continuously drawing interest on that money that they loaned me. Okay? And another way I've heard a per diem. At one point, one of the trucks I had, I don't remember exactly when this was or whatever, but I was talking to the banker and I was getting ready to sell it. And he goes, right now you owe this much money and your per diem is $2.71. And so basically I was paying $2.71 a day in interest just to borrow the money from the bank to drive that truck. So think about that for a minute. $2.71, so roughly $3 times 30 days, $90 a month. I was paying $90 a month sort of just to rent the money from the bank to have that. Not to mention that I had to pay the other part back too, right? So, but if you're borrowing money, it's going to tend to be, interest is going to be continuous or daily. If you're investing money, it's going to probably quarterly, possibly monthly, or weekly even, but it's usually going to compound less times per year than if you borrow money that way. All right, so note the time T is in years, and so the reason that's important, you might be given months. What if it says 6 months? Well, that's 0.5 or 1/2 years, right? So don't put 6 in there if you get 6 months, or if you're given 18 months, 1.5 years, right? T is in years. And the annual interest rate, R, is written as a decimal. So if you're told 5%, you move it over 2 places, 0.05, that kind of thing. A and P refer to amounts of money, so you typically round those to 2 decimal places. You typically round those to, unless you're told otherwise, you typically round those to 2 decimal places. Okay, so for purposes of this video, that's what we're going to do. All right, so what I've done here, I have a couple of different ones on each page here, and we're going to find the balance, the amount, if a certain amount is invested at an interest rate for so many years, and we're going to do 2 different compoundings. This one's going to be daily and semi-annually. All right, and we'll see that the amount at the end of it is a little different depending on how often it compounds. So here, if we look at this, we're looking for A. That's what we're looking for, okay? And this is my P, 2,000. Interest rate of 8%, that's R, and we write it as a decimal. So if we move this over 2 places, it's 0.08. That's T. T equals 5, right? 5 years. That's important, it's years. And compounded daily. Daily, how many days are in a year? So N equals 365. We're not going to worry about the 0.249997 or whatever it is, right? Every 4 years we have a leap year, and then every 400 years on the 100 we don't have the leap year or something. It's some number like that, I don't know. Or maybe 3 out of 400. 3 times out of 400 years we don't have it. Something like that. All right. So, but N is 365 daily. 365 days in a year. So we're going to use A equals P times 1 plus R over N to the NT. Now, let me say this to you, all you people that don't want to memorize formulas. Okay? I've taught it both ways, where you have to memorize it, where you don't memorize it, and all this other stuff. If you have to memorize it for your class, whether it's mine or somebody else's, write that thing down every time you work a problem. And work problems. Math is not a spectator sport. Hello. Okay? Work problems. Do some homework. Do some examples. Do some practice. And every time you do it, write the equation down. I don't care if you get sick of writing it down. And then, on top of that, spend 5 minutes a day copying the formulas that you have to know for any math test down. Just 5 minutes a day. That's not long. The problem is you got to make yourself sit down and do it. But if you do those things, you won't forget the formula when it comes to the test. So when I'm grading the test, or your teacher's grading the test, and they get there, if you don't know the formula, you're going to miss it anyway. I go, well, they didn't study. Yes, I did. No, you didn't. You can lie to me all day long and tell me you study, but if you're not writing down the formula, you're not studying. That's part of studying, if you have to know it. Okay? So, ain't no excuses. No excuse. You don't become great by providing excuses. Okay? So, A equals P times 1 plus R over N to the NT. So here we have A equals P, which is 2,000. And then we have 1 plus R, which is 0.08 over N, right, which is 365, to the NT, which is 365 times 5. Okay? Kind of got that all written a little too close. I don't know if I can move it or not, but it's all written kind of close together. So look, with something like this, I'm going to figure out my power. I'm going to go 365 times 5 in my calculator first, okay? I'm going to go 365 times 5 in my calculator, and I'm going to get 1,825. This power is 1,825. Okay, I'm going to write it down because it's typically going to be something that you can write down, and it's going to terminate. It's not going to be a non-terminating decimal or something like that. Then I'm going to go start in here with this fraction, and I'm going to add 1. Okay, I'm going to clear my calculator out. Got nothing in there but 0. It's cleared out. I'm going to start with 0.08 divided by 365. Okay, and I get a number in my calculator, but I'm not going to write it down because that's a little bit too much. I'm going to leave my 2,000 out front. I'm going to have 1.000211918 because if I add 1 to it, that's what I get. Now, that's what my calculator shows me. But again, I've mentioned this in other videos. I'm going to mention this in this one. Don't just punch that in. Your calculator has the value, so the order that I'm telling you to punch this in keeps you stored using the stored value. So you take that 0.08 divided by 365, add 1 to it, and you get 1.00021, blah, 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 okay? But I wrote down to 8 decimal places or whatever it is, but I'm going to leave it in my calculator. Then I'm going to take and raise that number. I'm going to take and raise that number to the 1,825 power. So you hit your power button, hit 1,825 equals, and so now let me see, let me change my color here. Now I have my amount is 2,000 times 1.491759313573. I'm going to write it all the way out, but that's what my calculator gives me, okay? That's what my calculator in my hand gives me right now. Again, I'm not going to punch that back in. It's stored in my calculator. I'm just going to hit the times button and hit 2,000 because, it goes way further than it shows me. So my amount is $2,983.51.8. So then what does the 8 tell the 1 to do? Round up to 52. So $2,983.52. So if you invested this money compounded daily, that'd be great if you could get it compounded daily, okay? For 5 years at 8%, also be great if you could invest something at 8%. Your savings account at the bank is probably like 0.25%, okay, or something like that. So 2,983.52, banks make money, right? Loan you money at 7% and give you money back at 0.25%. They make money. They wouldn't stay in business. $2,983.52. That is compounded daily. So now we're going to go down here and do the same thing. All my values are the same except what? I'm compounded what here? Semi-annually. So my N is going to equal 2. Right? If you make it to the semifinals, right? It's only, 2 semifinal games, right? And the 2 winners of that go on to play for the championship. So here, semi-annually, twice a year. All right, N is 2. So P is 2,000, the interest rate is 0.08, R, T is 5, okay? So what we're going to do is we're going to use the same formula, and guess what? I know I have it written down on this page. I don't care. Write it down again. We just talked about why. Write that bad boy down again. And write it again if you want to. Again and again. And then when it comes to the test, you won't forget it. Yeah, okay. That's fine. Don't write it down. A equals 2,000 times 1 plus R, we said was 0.08 over, and it won't, look, these won't always be back to back with the same numbers. That's just how I'm doing all these. And after I fill this in, we're going to talk about what we expect to get here. So my N is now 2, right? And then to the 2 times 5, right? To the NT, in parentheses, put a dot, whatever, not a decimal, but a times dot, right? Do you expect this to be greater or less than the daily compounding of interest? you should expect it to be less, right? Because daily compounded 365 times a year. This only is going to compound how many times a year? Twice. That's not very many times. Okay? Once and then one more time. That's it. So it's only going to compound 10 times the whole way through, right? Because here's your power. 2 times 5 is what? 10. So I've got my power of 10. I didn't need a calculator to put that in, right? You can check it with a calculator if you want to, but 10. There it is, 10. 2 times 5 is 10. So you start with 0.08 divided by 2 plus 1. And this one is rounded because it only goes to two decimal places, 1.04 to the 10th power. Now you raise it to the 10th power, however you do that on your calculator, and this one is going to go out much further. Okay? So let's keep going here. This is going to be A equals 2,000. I'm just kind of showing you here 1.4802442849183444. I hope I copied all that right. But again, that's not important. I'm doing that on this page. I will not do that from here on out. I will just write it down to a few decimal places and say, hey, don't round this off. Use the stored value in your calculator. That's why we're putting it in this order. And then take that times 2,000. Just hit that number times 2,000. And you get 2960, and 488 is 49. Okay? Now, realistically, if you borrow money from the bank and you owe them 1.3 cents, they're probably going to take 2 cents from you to make sure they get all of it. And if you invest money in it and you earned 1.3 cents, they're probably only going to give you 1 cent to keep it, okay? Or even 1.8. They're probably going to just give you 1 and keep the other 0.8 till you get to the 2 all the way, all right? We're going to round it for ease of sake. And again, I don't know that happens. I haven't worked in a bank and seen that in whatever. So, but look, it's about $23.03 less or so. So it is less. We thought it would be less, right? It only compounded twice a year. All right? So there it is. That's A equals P plus 1 over N to the NT. And then obviously continuously would be even more than daily, right? So if we did the PERT formula, A equals PE to the RT, then it should be even greater than 2983.52. We're not going to do that on this one. However, we're going to go over here and we're going to say, okay, now we're going to change it $6,000. $6,000 is my P. That's my P. So P is 6,000. And then is invested in an annual rate of 4%. So R is 0.04, right? Move it 2 decimal places. And then here, T equals 11 because that's in years, okay? And then compounded monthly, N is what? 12, right? N is 12 when it's compounded monthly. That's 12 times a year. So guess what I'm going to do first? A equals P 1 plus R over N to the NT power. So then I'm going to say A equals, not 2, I was about to write 2,000 again. 6,000, and then 1 plus R is 0.04 over N is 12 to the 12 times 11 power. All right, so again, I'm going to get 12 times 11 should be 132, I think. Yep, so this should be 132. So this is 132. So we're going to have A equals 6,000 times 0.04 divided by 12. Clear our calculator out, and then we add 1 to that. And we get 1.00 with a bunch of 3s to the 132 power. So then we raise that number to the 132. And we get 1.55157. And then so this is roughly going to be, this is going to be A is 6,000 times 1.55157. That's close enough, all right? Times 6,000. And we get 9309.429 is 43. And we're going to put a dollar sign there because that is an amount. $9,309.43. So that's 4% for 11 years compounded monthly. So then again, guess what? A equals P times 1 plus R over N to the NT power. That's pretty terrible. I'm going to fix that. That's really, really bad. Notice R over N is a fraction after 1 plus. It's not 1 plus R all over N. If you write that with a slanted fraction without, you're going to cause yourself all kind of grief. So we don't use slanted fractions because they're harder to keep up with than if we just use horizontal fractions and put everything in the top that we need in the top and everything in the bottom. Continuously. Oh, we don't need a lot of this stuff. This is the A. This is actually a different formula. I sat there and wrote this formula down without looking at it. This is continuously. So this is A equals P e to the RT. So we only need P, R, and T, which we have here, and my T is pretty bad, so let me fix it. All right, let me fix my T here. All right. So this is going to be A equals 6,000 e to the R 0.04 times T. Now here's the deal. Do you think this is going to be greater or less than 9309.43? It's going to be greater, right? Monthly was 12 times a year, but this is continuously. This is all the time. This is all the time. So 0.04 times 11 is 0.44. So this power is 0.44. And then you say e to that power is going to be 6,000 times roughly 1.552707-ish. Okay, because it keeps going forever. And then we're going to take that number and multiply it by 6,000. And we get $9,316.24, and 3 is the next number, so it stays at 4 cents. So to go from monthly to continuously, because the interest rate's 4% and it's only less than $7 more, okay, but it is more. It makes sense. Shouldn't be less, right? Make sure your answer makes sense. If you take a 20-foot ladder and place it 4 feet from the base of the wall and lean it up against the wall, it doesn't reach 25 feet up the wall. It's a 20-foot ladder, right? Make sure your answer makes sense. All right, so let's continue on with these. We've got several of examples of these, just like this. So here we're going to put $12,000. We're going to invest it at 7% for 5 years, compounded quarterly and weekly, okay? Compounded quarterly and weekly. So again, the quarterly N is 4. Weekly N is 52, right? 52 weeks in a year. So this is A. That's what we're looking for. This is P is 12,000. R is 0.07. T equals 5 because that's in years again, right? So we have the same values for everything here except N. So we're going to say A equals P times 1 plus R over N to the NT. And I'm going to write the formula down for both of them. Okay, so now let's start filling stuff in. The first one up here, A equals 12,000 times 1 plus 0.07 over N, which is 4 in this case, and then 4 times 5. Okay, so that's going to be 20. So we're going to have 12,000 times some number to the 20 power. And then we're going to have 12,000 times some number, right? And then we're going to get A equals some dollar amount over here, right? That's what's going to happen. So 0.07 divided by 4 is 0.0175 plus 1. So 1.0175, you don't have to round that one, to the 20th power. So raise it to the 20. We get 1.414778, so whatever. All right, and then we just do times 12,000. Don't key that back in. That's already in there. Times 12,000, and we get $16,977.34. 34 cents. Okay. So then the next one, it's all going to be the same except the N, right? So we're going to come in here and go A equals 12,000 times 1 plus R. R is 0.07. N is the thing that's different here. It's 52 instead of 4. To the 52 times 5 power. All right. So do 52 times 5 and we get 260 for the power. Okay. So we're going to have 12,000 times something to the 260. Then we're going to have 12,000 times something here. All right. And then we're going to have that something in dollars and cents over here after we do all that. So what is that? 0.07 divided by 52 plus 1. This one needs to be rounded. 1.0013. I mean, when you write it down. Okay. Next number is 1 after that 6. But again, I'm not actually rounding that. I'm just writing it rounded down. When I said need rounded, I just meant to write it down. Okay, so then raise this to the 260 power, and you get 1.41873336. Okay, it's 588. Anyway, all right. Again, I'm not rounding it. Have it in there times 12,000, and we get $17,024.80. Now, we just got more on this one. So it was compounded weekly, compounded quarterly. Which one was compounded more often? The weekly, so it should have been greater, right? If you're adding interest more often, the same amount of interest or the same amount of money, right, to start with, if you compound the interest more often, you should end up with more money, and that's what's happening right here. Okay? That's what's happening right here. All right, so let's look at another one. 6,000, 9%, 15 years annually, 6,009%, 15 years continuously. So for this one, A equals P times 1 plus R over N to the NT. And this one is continuously, so it is PERT, PE to the RT. So annually is N equals 1. Again, we're in years. So this is T equals 15. 9%, R equals 0.09. Let's see, 6,000, that's my P is equal to 6,000 here. And I'm looking for A, right? So same thing here. I'm looking for A. I got P. I got R, which is 0.09. I got T. And this time continuously says use this formula right here. All right? So the setup is the same. Again, they're not always the same. I'm just showing you here. So which one do we think should be greater? The annual, one time annually, or continuously? Yes, continuously should be more. I can't talk. All right. So now let's start filling this in. We're going to have A equals 6,000 times 1 plus R is 0.09 over 1. 1 times 15. All right. So A equals 6,000 times something to the 15 power, because that's exactly 15. And then A equals 6,000 times something. All right. And that'll give us our final answer out here of A equals something with dollar signs on it. So let's see. We're going to take, this is going to be 1.09, right? And then 1.09 to the 15 power is 3.64248. Seems big. 15 years, I guess, huh? At a high interest rate times 6,000 is $21,854.89. I'm a little taken aback at how big that is, so be anxious to see if I punched something in wrong or did something incorrectly there. 1 plus R over N to the NT times P. Looks right. Okay, so let's just check this on this other one. Should be more than 21,854, right? So the amount here is going to be 6,000 E to the RT 0.09 times 15. Okay, so that's going to give us 0.09 times 15 is going to be 1.35. And we're going to take E to that power. So this is going to be 6,000 times 3.857425553, blah, 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 blah. Okay? And we're not rounding that. We're just leaving our calculator times 6,000 is $23,144.55, which is greater than 21.8 whatever. So there's my dollar sign for that. So $23,144.55 compounded continuously there. Okay? So I hope this helps you with compound interest. We did both the formula for continuously and for N times per year.